twice, Big Four Consulting, and I was in the Air Force for 28 years. I'm a retired cyber warfare officer. It's great to see you all.
Yeah. Great to see you too. Now, LinkedIn has been having some troubles, and I'm having some small technical issues. So I'm just going to try and get that working in a minute, and we'll see if we can go live over there too. LinkedIn had an outage today, which of course happens the day that we're trying to stream over to LinkedIn. But we'll try and get that going. If not, then the main show will be here on Crowdcast. So great to have everyone with us today. Not to waste any time, I think perhaps we'll get into a little bit of the presentation that we're going to today. So I'm going to be presenting how large organizations can protect their attack surface on GitHub. And we'll have Chris and David adding their knowledge and expertise along the way to kind of add more context and challenge some of the initiatives here. So I'll just share my screen.
I'm trying to get a little color, Mackenzie.
And, all right. So how do we protect your attack surface on GitHub? So just a little bit about what this presentation is going to outline. So we're going to talk about why we need to take GitHub as an attack surface seriously. There may be people listening in here that say, well, I use Azure DevOps, I use GitLab, I use Bitbucket, I use one of the other version control systems, therefore this doesn't apply to me. Actually, it definitely does. We'll explain why throughout the presentation. And then we're going to talk about how we can manage this attack surface. So, how we can actually start to take charge of it a little bit, get some control over it, and most importantly, get some visibility. And then at the end, we're going to go into kind of a demo of what GitGuardian's public monitoring solution actually looks like and bring together some of those elements. So I want to start real simple, just to get everyone up on the same page. I'm sure everyone's probably aware, but I always like to start at the basics. So I'm going to be talking a lot about secrets in this. So what do I mean when I'm referring to secrets? I'm not talking about industry secrets. What I'm talking about is kind of digital authentication tokens. Typically, this is going to be like your API key, your AWS credentials, your database credential pairs, your security certificates. So secrets are really, you think of them as the crown jewels of your organization, and they grant access to anything and everything. And attackers are really targeting these specific things because they correctly authenticate themselves into systems. And what's kind of interesting is that attackers can actually use these secrets to discover and harvest more secrets. So they can take a secret that gives access to your messaging system, find that to find out where your internal employees have shared additional secrets. So you can really elevate privileges or move laterally into different systems. And so this is the easiest way. And one of the keys of it is that attackers are correctly authenticated when they're using secrets, meaning that no alarm bells will go off. They've used the key to come into the door and they've got the code to turn off the alarm. So there's nothing in there to say that, hey, there's an intruder in our systems if they're correctly using secrets. So that's what I'm talking about when I'm referring to secrets. And we actually use these everywhere in our software development lifecycle. And lots of different teams need them. Developers need them to kind of test services. They often end up hard-coding them into source code. Your DevOps engineers need them to run their pipelines. You need them, obviously, to test and build your applications. You need them in the runtime. So really, we end up with these kind of secrets that are relying on lots of different elements. And they're kind of secrets that connect to third-party systems that share different secrets with each other. So it gets very convoluted into who's handling these. Now, if you take this to an organization at scale, then what you really have is you have hundreds of secrets and no real way of kind of knowing where they've all sprawled to. Okay, you have a secrets manager, but every now and again, those secrets break out of that, right? You might send them to a developer, or they may be used by different people. They could be saved in different areas because requesting them from the secrets manager is a pain. So one of the big problems that we have is that we really don't have visibility over like what these secrets are, how they connect into stuff, and who ultimately holds these keys to the kingdom and where they all are. So we're going to be talking about GitHub specifically, and why we need to take these threats seriously. And I said at the start, even if you're using Azure DevOps for your main repository for your organization, even if you're using Bitbucket, GitLab, it doesn't matter. And the reason is really because of the scale of what GitHub operates at. So we just take a quick look at kind of what's on GitHub. Then there's 100 million developers that are using GitHub. There's 300 million repositories and 4 million organizations. So if you as an organization don't use GitHub, your developers probably will, because it's kind of like, LinkedIn for developers in a way, where they share their portfolio on there. They could contribute to community efforts. They might have open source projects. Your developers might be contributing to open source projects relevant to your organization. That all happens on GitHub. So the important thing is that it's not just what your organization uses as a VCS. It's kind of everything that's surrounding that. That kind of gives it quite an interesting kind of dilemma of working with something as large as GitHub in these organizations.
One of the things we've seen at TAG just over the years is just astonishing. It's all very organic growth, but we've seen the size and growth of GitHub pretty much almost like quarter Xing, almost 2Xing every year. More and more companies are moving to open source, and so it's really fascinating research that you get.
Yeah, and because there's a lot that happens on GitHub. And it's like the de facto community space for all developers. And so, if you're looking to hire a developer and you want to check out what they've done, you're going to go to their GitHub profile. And it's really important developers have GitHub profiles, so that they can display this. So, just about every developer, I'd be hard pressed to find one that isn't using GitHub in some way or another. And that's why their growth is so aggressive. And any meaningful open source projects are pretty much all on GitHub at the moment.
The reality is this is what drives businesses, right? It's our code now that is driving our products, that drive our revenue, and those kinds of things that are super important to not just the revenue of an organization, but the customers that they serve with the products that they build. And as we look at the shift that you talked about in some of the adversaries that we're facing, they're going after these because it gives them access not just to maybe even a target set of opportunistic activities, but a multitude of organizations because of how they're being used and how they're being promulgated. But I think it's also a great opportunity. I think you're going to talk about this, right? This is scary stuff. This bad things can happen. But I also think it's a great enabler, an opportunity to start converging capabilities and team efforts in a way that increases our time to market for product and features, the ease and use of things like automation and tools and those kinds of things. So I hope that our audience really kind of gleans those insights, not just the scary stuff on why it's an attack surface, but the opportunities on how we can make teams more effective.
Yeah, absolutely. And there's a reason why it's so popular, right? And it's not going anywhere. And it's the same reason why these secrets have become such a big problem in our in our vulnerabilities, is because by connecting into these third-party services, we can offload a lot of the troubles that we have. Like we can do authentication using a third-party service like Okta, or we can have a managed database, or we can use cloud infrastructure. We don't need to run our own servers. This enables us to build and create more things at a much rapid pace. It's all overwhelmingly good for an organization. However, it creates a security concern. And so the idea is not to kind of go back to the dark ages and start writing code by hand again, but it's to say, hey, here's the issues. Let's face them and let's come up with creative solutions to solve them. And ultimately, yeah, that's what we're going to be talking about. So moving on, we're used to talking about public attack surfaces in other areas, right? We have our cloud environments. Elements of our cloud environments may be public. Perhaps they're misconfigured. So they shouldn't be public, but they are. You see all the headlines that have exposed Amazon S3 bucket. We have our dark web, forums. We need to monitor the dark web for our secrets that are leaving there, for username, passwords, for our employees' details. These can be shared. So, and a lot more. Remote endpoints, having exposed APIs that aren't meant to be. All of these different things, social media and our pay sites. But now what we're saying is that we really need to add into this mix public GitHub, because your developers are on it. They're going to be pushing code. They're going to be contributing to different areas. And, they can accidentally, also, we'll talk about why this is so easy, expose your organization's code publicly. It's very easy to do. And with the sheer scale of code that happens, at GitHub with remote working, we're all on our personal laptops now, or at least we use them like that at home. So we can often end up having this code sprawling everywhere. So we need to start thinking that GitHub is an attack surface, like how we think about all these other kind of public facing forums and sites and infrastructure. So let's talk a little bit about secrets leaks on GitHub. Does it actually happen? So we'll dive into some research that actually shows, yes, it does happen. It's something that you need to be worried about. And it's really not hard to find. So if a developer is contributing source code into GitHub and it's public, I think what people also need to realize is that all that is not just publicly available. It's actually broadcast on GitHub's API. But just by going to GitHub and using, GitHub's search feature, for example, you can type in what they call GitHub dogs, certain patterns that are trying to try to find secrets in there. So here we're looking inside environment variable files for an AWS key pattern. And we've found lots. We've found, lots and lots of different results that are showing us that. And there's thousands of different types of secrets. So we can formulate these queries to try and find secrets in GitHub places. Now, this is a very rudimentary way of doing it. Attackers are actually much more sophisticated than this. But this is a good example just to show that the level one, you don't need any hacking experience. You don't need any kind of pen testing experience. You can just jump onto the GitHub search feature and you will find valid secrets by using this technique. And one of the other elements of this too is that when it comes to search features, the search features on GitHub, is that this is only actually looking at one top layer of what's happening in GitHub. So there's actually a whole bunch of layers underneath that. So this looks at just when we go into version control history, we have the top layer, which is the application of the project at its current state. And then we can peel back different layers of the history of different various kind of time periods where that project has been done. Now, the search won't search into all of that history. So it's only searching a very small percentage of GitHub on that top layer. If we go deep into that, well, then we can actually try and uncover huge amounts of sensitive information that has actually kind of been forgotten about in the history. An example being that if we commit a secret by accident, if we go to delete that secret, we're probably just going to commit over top of it. So it makes it a little bit harder to find, but anyone that knows what they're doing will be able to go through GitHub's history and that project's history and uncover it. So even though we will get results using just a search feature, the actual kind of juicy elements are actually much deeper than that. So the attack surface is much deeper than just what we see on that top level.
This is actually opening up it's Pandora's box of challenges, especially, just the amount of secrets that are out there. And it's not just isolated within DevOps or DevSecOps. It's causing a massive GRC problem. I mean, companies are having a hard time keeping up with their compliance components because there's so much PII out there. There's a lot of HIPAA data out there, and I know developers don't try to put out dirty code, but sometimes it just happens. It's a lot of probably say 70% of it's just overlooked, and so being able to go off and search across this repository is just it's creating a lot of business challenges as well as development challenges, and it's growing to become to eat itself.
Yeah, absolutely.
Mackenzie, you talk about keys, right? We talked about the secrets component. Chris mentioned some PII. Are there things that you think are particularly materially dangerous to organizations with respect to the sensitivity of information? Maybe double click on that a little bit. What other types of sensitive information can be found on GitHub?
Yeah, well, the core ones, the ones that are most dangerous, are definitely going to be those secrets that are out there because you can find them programmatically. So, what I mean by that is you can build scripts that will look through the GitHub API and try and pull out these secrets. But then the next step in that kind of programmatic analysis is to then test secrets. So you can just let this run, go about your day, come back ready to do your nefarious activities, and then your script could have a list of valid credentials, by automatically calling the API. So that's kind of the most scary because attackers can action on them really fast. We do have GitHub being used for kind of intentions that it's not made for. So during COVID, there was lots of kind of PII spreadsheets that were kind of somehow ending up in public GitHub repositories. This isn't really what it's made for, but it's increasingly become, that central storage place for everything. So there's lots of different things on GitHub, but when we're talking about what you need to be worried about the most as an organization, it's definitely going to be those secrets that are going to grant them access, attackers, into your organization, because they can immediately test them. If you find a random key on the ground, all right, you've got a big challenge of finding out what does this key open, what part of town is it from? And it's going to be very hard to find the correct door for that. Right. With secrets, hey, we can just make a call and see what comes back. And if it comes back valid, I say, okay, I know that that's the key for this door. And all of that can just be run in the background. So that's why I think it's particularly scary. And anyone can actually, if you're curious, anyone can actually see the GitHub API. So if you go to api.github.com/events, you don't even need authentication. That's a complete ledger of everything that's happened in GitHub in the last few seconds. So, attackers can just look at that ledger and see exactly what's happening and if there's any secrets in there. It's more than public. It's kind of broadcast out to everyone to kind of see. So I think maybe now, let's talk about some real life examples of where secrets have actually ended up in GitHub, and when malicious actors have actually found them and used them for different purposes. So Toyota had an application called T-Connect, it's a mobile application, and that was in a public repository by mistake. It was actually a contractor that had that. That repository was actually public for 5 years before anyone actually noticed that inside there was a credential that gave access to the database of customers using that application. So for 5 years, no one actually knew about this, but any nefarious actor could have been scanning for certain features and actually found that. I'd be very surprised, based on how you can automate these processes, if an attacker actually didn't find it. It just took 5 years for a good guy to actually report it and say, hey, I don't think that this credential is meant to be there. So what did that give access to? So it gave access to nearly 300,000 rows of PII of the customers using Toyota. So you may think, okay, there's no passwords or credit card details within that, which is often the case with data breaches of this kind. But this is gold for an attacker, because I have a list now of people that have recently bought Toyotas, because it's a modern feature that they have. So they probably have money. I know they have a Toyota. I know when they've bought their Toyota. I know when their possible services are up. So I can use all this information to conduct these very real-looking phishing campaigns. Right? People aren't falling for the Nigerian print scam anymore. They're falling, and attackers have gotten much more sophisticated. So this is an example of when a real secret was leaked publicly in GitHub repositories. And we have some other examples here, but one of the things that just to talk about a little bit is GitGuardian. Every year we release a study of what we've found on github.com. So actually, throughout the entire year, we scan every single public commit that's made to GitHub. So every single time you submit code or you make a push to GitHub, that goes into that public ledger, and then GitGuardian will scan that for secrets. At the end of that year, we publish our results of how many secrets we actually found. So coming up in March, we're going to release our results for 2022. But here's a quick poll. How many secrets do you think GitGuardian actually found throughout the year of 2021? Now, a few of you have already found it, but on the button on the side of the Crowdcast panel, you'll see there's a poll in there that you can participate in. So right now, 25% of people think that it's less than 2 million. Most people, about 50%, think that it's 2 to 3 million. Okay, it's starting to change a little bit now. We're getting a few more people think it's 5 to 6 million. A lot more people think it's 5 to 6 million. That's definitely the runaway one. So
Mackenzie,
Yeah,
while you're waiting for your poll results to come in, I thought what was especially compelling about your Toyota example is the implications for other kind of emerging technologies and capabilities. So when we look at cellular vehicle to everything and how vehicles will communicate, how that software is updated. At TAG, we did a historical analysis of attack campaigns. We believe probably starting in the next 12 to 18 months that we're going to see a significant increase on the number of campaigns against critical infrastructure. When you look at green technology starting at home, I have a Tesla system in my house for solar. That thing is updated about 5 times a month. I have really no idea what's going in there, how it might affect other parts of my home. Not that it's thoroughly sophisticated at the cost I do Neuman, but my point is that we need to really start thinking about the implications of material impacts over the horizon, not just in what you're going to describe now. That should be the call to action on the results of your poll today. This is what does this mean for the use of other technologies and capabilities?
Just add what Dave was just saying. The other thing that stuck out with me is the thing sat there for 5 years and it was, nobody detected it. That's very consistent with what I run into. A lot of the work that I do with the U.S. government, most of the vulnerabilities that we see don't get detected until 2 years after into this, into the when it releases its payload. So these things sit there for 2 years at a minimum with the government, and it's very daunting. So this is why we've got so many big hits or big breaches, and like with the VA and State Department and some of the other kind of major agencies, because they just don't detect them.
Yeah, and it's kind of, and it's really hard to detect them. That's what I was saying at the start too, because all right, you've got the credentials for this database. If you don't have additional parameters set up of who's meant to access that database, right? Then if I've got the keys, that sends off no alarm. So an attacker goes in, steals the part, steals the database, clones it, goes away. As far as that the organization is concerned, in this case Toyota, that everything's fine. So how would you detect that if you haven't kind of got been established with that? And to the other point that David was making, it's incredibly important that we protect our physical infrastructure and as well. And it's these inadvertently open sourced is kind of what I call it, is when you've got closed source software that makes it to the open space, which happens all the time.
Yeah.
I don't think open source software is insecure. I think closed source software that becomes open source is because we're not thinking about it with the same mindset. So if we started thinking about our infrastructure, if we made it all open source, I'm sure there'll be plenty of arguments for and against, but then at least we know that it's open source, and we're going to take extraordinary efforts to make sure no secrets are in there, that there isn't exposing any business logic flaws, and lots of people are going to be looking at this. If it's closed source and it finds its way open, we have none of those protections. So yeah, but moving on, just looking at the polls, so over 50%. That's just surprising. The bunch is onto it. There, over 50% think 5 to 6 million secrets were found, and that is the correct answer. 6 million secrets were actually detected in this state of secret sprawl. So that QR code takes you to the report if you're interested in kind of learning a little bit more what's in there. We don't have the time to go through the entire report, but some of the takeaways of that. So 85% of the leaks actually occurred in personal public repositories of developers. So 15% of the leaks happened in repositories that belonged to organizations. So that in itself is really scary when you look at that number. But 85, so the vast majority, actually happened in developers' personal repositories. And if you want to look at kind of the numbers that we have, on average, every 3 commits out of 1,000 contained at least one secret. So that's huge. So 1,000 commits may sound like a lot, but that's a couple of seconds in GitHub. So if you've got these automated bots scanning for secrets, right? I mean, you need to wait 10 minutes. By the time you've come back with a coffee, you've found valid credentials. Now, they may not be to critical infrastructure, to a large organization, but it is definitely still interesting all the same. And so when we actually take a little bit deeper look into these secrets as well, you may be wondering, okay, so why is it important that when these leaks are happening on personal developers' accounts, why is that interesting as an organization? And it's actually interesting for a number of reasons, because this is where actually the most amount of organizations' keys get leaked. And one of the reasons is that you're operating outside the normal bounds of your organization. So as an organization, you have no authority to be able to check what your developers are doing on their personal time. But through their job, they may have access to lots of sensitive information and these keys. And so it can take just a small misconfiguration. If you have misconfigured your Git repositories incorrectly internally, for your organization's code to end up public. It happens all the time. And it also can be the case that they're working on personal projects that stem from some code that happened in the organization. Maybe they're working on an improvement in their own times to present. Maybe they're working on a side project and they've kind of taken organizational's code. You may think that this wouldn't happen in your case, but it does, right? And there's not ever really any malicious intent from the developer. but there's kind of not understanding the consequences of that, or thinking, hey, no one's going to care about my personal repositories. I have 2 followers on GitHub. No one's going to be able to find this. But as I said at the start, this is all broadcast on the GitHub API. No one needs to be following you to be able to detect those.
And Mackenzie, one of the things of value, especially on the personal accounts, is typically organizations and enterprises tend to make you have better cyber hygiene. So they make you rotate your keys, change your passwords, do all that. A lot of times, most people don't. They won't change their, personal passwords, or personal information, or personal credentials, for years. So,
yeah, and you know what? If you work, if I'm an attacker and I'm specifically trying to target, Google, for example, just because it's not a Google credential, right? If I have the credential for a Dropbox account of a Google employee, hey, that still might be really interesting in me and trying to successfully launch an attack on that company, right? So it's kind of like, like just because these aren't keys to your organization, hey, these may be from your developers or engineers that have critical access to infrastructure that even on their personal accounts are, it's really critical. And like an example of something we see a lot of. It took us kind of a little bit to try and figure out why we saw this, but we saw huge amounts of Slack tokens for organizations that were leaking publicly. And when we kind of looked into it, what it really is often developers in their own time will build out bots that help automate parts of their job or control it. And one of those was Slackbot, to kind of send messages where things were happening into their work's Slack account. So misconfigured, you could end up with a token that gives you far more access than you intended to. An attacker can use that. But these are the type of projects that we often saw in personal public repositories. And as an attacker, that's still really interesting for me, because what I can do is I can start posting phishing messages in a company's Slack channel that actually look very, very legit. And because it's coming from the Slack channel, right, it's not an external, I've broken down one of those barriers of trust. So that's kind of like some of the interesting keys that we really find. And if we look at, what are the types of keys that we find, we get some interesting results. So one of the questions is, how can we be sure that we found 6 million secrets and not 6 million example secrets? So we can actually validate a lot of these secrets. So if, for example, we find a cloud provider key, we can check with the cloud provider, make sure that key is valid, same way that the attackers would, and then we know that key is really valid. And we can also do a lot of post-examination on the incidents automatically to make sure that there's no words for test or example or replace key in the file. So we really narrowed down that. But we left here with actually what we find, and it's quite concerning. So what we have in dark is what we found in the latest report throughout 2021, scanning throughout 2021, and then the light green was actually what we found before that. And so you see that there, we're finding
Mackenzie,
more and more. Sorry,
I'm sorry
go for it.
To interrupt. What's the jump in other? What is other there, and why such a significant jump there?
Yeah. Feel free to interrupt with great questions like that. So that other category is really, we've put it there is because we're not entirely sure what those keys do. For example, it's a private key that doesn't have explicit context in the code as to what it's connecting to. And so one of the reasons why there's such a huge jump is that we made some big changes to our detectors and how we actually found these credentials between 2020 and 2021, because this other category can set off a huge amount of false positives, because it's really hard to distinguish whether or not it's a test credential or a real credential. And so what we actually were able to do, at the start of 2021 was integrate what we had been learning after scanning GitHub for 4 years and plug that back in to actually finally determine if these other categories were actually real or not, because we would often ignore them if there was no way to kind of definitively say, hey, yes, this is a credential. So that other category is really the unknown. And why it's interesting is because these are the keys that are actually really, really hard to find, even with secret scanners. So if you're an attacker, you have one thing, you have a couple of advantages, but one of the advantages that you have on your side is time, because you can afford to investigate lots of time into trying to find out what these keys do. Whereas AppSec engineers, security personnel, hey, we're all busy, right? Like none of us are wondering, we're not going to investigate something that, something that may be a test credential. So that jump is significant because that jump represents kind of what we're really confident are real keys now, because we've improved it so much. And, and attackers are going to be able to find these, even if they're not using sophisticated scanning, because they've got time. They can dig into the code and find out if it's real, if it looks interesting enough, if the target is interesting enough. So that's really interesting.
That kind of begs another question. I mean, you talk about, I mean, this is a big scary one, especially around cloud providers. But are you seeing any areas where things are improving, or people are, getting better, keeping secrets out of their code?
Yeah. So yes and no. So if we hone in on cloud providers for what you said there, this is a great question. Cloud providers is probably the most scary because it's your cloud infrastructure. And hey, if it's for your organization, then that's really scary. If it's not, I can still mine Bitcoin on it. So, happy days for me as the attacker. So I'm going to start with some positive news. There are certain types of cloud provider keys that we saw trend downwards in what were leaked between 2020 and 2021. So one of them was AWS keys. We saw a trend down, not significant, but a little bit of a trend down. And the other were Azure just Azure DevOps keys, sorry. They were starting to trend down. And so the reason why we found this is because those companies have put in significant time and energy into trying to educate developers. Their messaging has changed, and they're also trying to find these keys, and in some cases like AWS, they will auto revoke them. So a happy days here. The problem is that at the same time that happened, a whole bunch of new cloud providers came onto the market. We had PlanetScale, we had Superbase come onto the market in 2021. And, we can track the growth of those companies by the amount of leaked secrets that they're having. And so the cloud provider keys that were leaked increased both in percentage and in general numbers, even though some areas of improvement were being seen. So it shows that, hey, we can actually start to tackle this problem with education, with a shared responsibility model, with some providers coming to the table and helping. But we're so far away from having a meaningful change generally that I'm going to say, no, we haven't seen, a big improvement of these areas. All right, so if we move on, we have some fun facts here. I'm just looking at the time. We're gonna. I've been yapping away for a while, so we'll get through some of the meat through now. But some fun facts. When are these keys most leaked? It's actually on weekends, right? And this makes sense because you're outside of those parameters put in place by the organization, those security parameters. You're working on your personal projects. You're catching up on the work that you need to present on Monday, anything like that. And then that's actually when a lot of the leaks happen. Yeah, a fun story that I have is one of my friends was working. His wife went into labor, and he very quickly scrambled to kind of commit his work and leave. He didn't come back from maternity leave for 2 weeks, realizing that the last thing he did was push admin AWS credential publicly on GitHub. He created a whole fire, then shut the door behind him. And I can tell you that he wasn't interested after your baby was born about helping out at work. He wouldn't have even realized it. So, when you're under stress, these certain external factors can really contribute into making a simple mistake that can be catastrophic. And if we exclude weekends, it's public holidays. So same reason of actually when we do it. And we're not sure why, but November 20th, the biggest day of the year for leaks. I think one day has to be. So I think that just happens to be it. But so yeah, 66% increase in the amount of share of secrets based on a normal day. All right, so how do these keys end up exposed? So their secrets can be committed for testing purposes, and even if it's and often these keys can be valid in different areas. So you want to quickly do something, you get it working, you hard code a credential, you move on. One of the big ones we see is when a private repository is actually made public. So you have all this history that comes along with it. It's not just the top layer that you're making public. You're making that project's entire history public. Yes, you can squash the history, but that also has negative effects in terms of understanding how that project was built. We're seeing a lot of sensitive files get added in. So .pem, which is a certificate file, or .env, environment variable files. It's very simple for a developer. He's made lots of changes. He or she has made lots of changes to different documents, and does git add all, and captures with that a whole bunch of documents that aren't meant to be in there, like .pem or .env environmentals, and accidentally pushing to the wrong repository. I think it's it can be really easy. We have GitHub is actually set up where you have one account for both your personal and professional use if your organization is using GitHub. So you're already correctly authenticated on your machine to both your work and your personal repository. So a small configuration error when you set up the project, which happens where the remote is at a different location, then you can accidentally end up pushing your code public quite easily. So just some of the ways of why we're actually leaking these keys.
Do you typically just look in real time on this stuff, or can I claw back and look at a historical reference?
Yeah, that's a great question. So we've actually been, and this is kind of interesting from an adversarial point of view too. So when I said a couple of times that you can actually look at all of GitHub on their event streams, on their API. And so what attackers do and what we do is we actually have a complete record of everything that's happened on GitHub for the last 5 years, and regardless of what's happened since. So you've deleted that repository, it still exists somewhere. And why that's important to say is that it's not just us. This is public domain. This is publicly accessible code. So you can so other adversaries are storing this and tracking it as well. Like on Wayback Machine, you can see an internet page from 2 years ago. I can see your repository from 2 years ago as well. And code isn't exactly data intensive, amongst other things. So this is not it's not such a difficult technical challenge. But one of the things that makes it good is that if you're an organization and you want to see, has our secrets ever been publicly exposed, then you can actually do that because we have a complete record of it. So yes, we're doing it in real time, but we can also, regardless of when an organization may join with GitGuardian, we can also kind of go back and see, hey, what's actually happening here.
Mackenzie, what about test secrets that aren't really valid for anything else? How do they play in?
Yeah. So I mean, when you talk about test secrets, you have test credentials that are real and were used to test something. You got test credentials that are real but for a test environment, and then you have test credentials that are kind of that are just kind of fake data. All three are actually interesting. So the first one's obvious. The second one, you may have a staging environment. That's still interesting for me as an attacker because I may be able to break through that and get into your production environment. A funny story. Again, some of my friends were pen testing some environments of a company that will name nameless, and the company gave them the challenge, hey, we're going to give you developer credentials. Can you break out into production from our sandbox? And in the CI/CD environment, he changed one line of code. The line of code was he changed dev to prod in terms of the environment variables used, printed out, and you got a list of all the production credentials. So, test credentials to sandbox environments are still interesting. And the last one, test credentials that are dummy data. Well, if it looks like a real credential, these won't be flagged as valid credentials, but why they're still interesting is not the secret itself, but because you've put that in there because you're intending that someone replace that with a real credential. So that means that credential is hard-coded. It's a poor development practice that's kind of being encouraged. So even though that secret isn't valid, then eventually that's going to be replaced by something that's valid. It may not get put into the Git repository, but as an attacker, that's interesting to me because now I know where to dig to try and find. So it's not as critical, but it's still interesting. So test credentials can still be very interesting in how they play out in this. All right, so let's talk about how you actually manage your attack surface on GitHub. How does this actually work? So first, what we do at GitGuardian is we're able to automatically define your perimeter. So one of the hard things is that you're an organization, you go, okay, I want to see if we have any secrets that have been leaked to GitHub. I want to see what my employees are pushing, if they're pushing organizational code. How do I find all my employees, right? They don't use their work address. They may use kind of different names. So how does that happen? Well, we actually are really good at being able to build up what we call your perimeter, and that's of developers that are with your organization. And we do this in a number of ways. We look for your organization's domain name and email addresses, and then we automatically add anyone that's using those domain names into your perimeter. But what we can do is, because GitHub is unique in that you have generally one account for both personal and professional use, we can actually add that whole account in, then find all the email addresses that they've ever used in their history, and then find anywhere that those email addresses have been used, and get together a huge perimeter of what your employees are actually kind of pushing on GitHub, even if there isn't an apparent relationship to the organization. And we can also look into what they have mentioned about the organization in their bio or other areas. So, and because we have the complete record of everything that's happened on GitHub for 5 years, we look back on this immediately, so we can automatically build out this huge perimeter very accurately of people that are connected to your company, even when the line to your company, it can be quite ambiguous when you're looking at it, just from person to person. So that's the first step, because that's actually really difficult. Identifying the perimeter is actually a really challenging part of being able to do this, because if you're missing a huge number of your employees, then you're missing that, that actual attack surface there. So that's pretty much kind of how we can build up your organization's perimeter. We have other tricks as well, but we can go into this on a case-by-case basis, but it's very accurate, and I guess the main thing is it's automated, because when you're talking about a large company with thousands of developers, this is a big job if you're trying to do this manually.
Does that create risks though within the organization, especially kind of using this model?
Yeah. So the using GitHub like this way does create risks for the organization in terms of using the same account for personal and professional use. But that's also just because of how GitHub has been kind of set up into making it easy to be able to kind of switch between the two. So there is risk in that dual purpose accounts, but that risk isn't really going away, and this is a way really to kind of capture that and kind of and almost use that to an advantage in mapping out your attack surface as well. So once you've built up that perimeter, what you can do is you can kind of continuously scan the contributions of all the people in your organization, and you kind of get justified reasoning as to why they're in there, and any changes that are made are scanned in real time. So within a few seconds, those changes that an employee pushes code on their personal stuff, personal repositories, GitGuardian can scan it and actually kind of uncover that in those public repositories. All right, so what we might do is a very short, quick lightning demo. Well, hang on, we'll go one more slide and then we'll do a lightning demo. But an overview of what GitGuardian's public monitoring actually helps us do. So we define the perimeter, which is what we've just been talking about. So that's a really challenging part. That's quite unique. And then we actually scan the information the commit's made for secrets, right? So it's very important to use high quality detectors so that you get, low amount of false alarms and kind of don't contribute to that alarm fatigue. There's lots of ways you can do that, post-validation, by getting rid of test credentials and also checking if the credentials are valid. And then we also help with remediation. Now, remediation is actually really difficult. Everyone focuses on detection, but you'll come up with thousands of results. It's just what happens. And you need a good process in place to be able to remediate it, which is going to involve multiple parties. It's going to involve the developer that pushed the key. It's going to involve the team that created that key. And it's going to involve the team that's going to rotate that key. So these are the three areas that GitGuardian public monitoring really helps organizations solve in protecting their public attack surface. So a very quick demo. I'm conscious of time on here, so I don't want to take up too much, but I do want to show everyone kind of what it all looks like. So let me here just get into the actual product itself. So here we have GitGuardian's public monitoring solution. So the first area that what I'll see is our perimeter. So what the perimeter shows us is this is everyone that's been added that we're publicly monitoring. These are all dummy. This is all dummy information. In case everyone's worried about data exposure. But here we can see an account that has multiple email addresses. This is because they've committed with a personal email address and a professional one. So we're monitoring everything and all GitHub users that are connected to those email addresses. In a real life scenario, you would have multiple, but obviously as this is all kind of dummy data, you have a couple, but it lets you know exactly how they ended up in their perimeter. So we have a lot of developers in here, several tens of pages of developers in our perimeter. And what we can actually see is I'm going to go down to the incidents tabs. We can actually see where secrets have been pushed. So you can actually, sort secrets very quickly by trying to figure out, hey, do we have any secrets that are actually valid? It's test data, so obviously we don't. But also, ones that are critical for our organization, critical risk or high risk, so that we can start sorting through the information really quickly. And we can also automatically assign the risk factor based on what we call playbooks, which are parameters set by an organization. So if you have a really high exposure to, AWS, then an AWS credential is going to be critical for any case. And when you actually look into the incident, it will show you the secret itself. It will show you whether or not it's currently present in GitHub still, or if it's been deleted. So if it's been deleted, it will still show up here because it has been exposed and it still needs to be rotated. It will let you know whether or not it is a valid credential and if it can be checked. So here we say that the secret is actually invalid, and it will let us know when it was last checked as valid. So it's been invalidated, but that was 2 days ago, 3 days ago, however long, so you can monitor it. And one of the coolest features is that you can actually share this with the developer. So here we have the developer involved. If I share this instance, then you can send an email to get feedback, and it will send a questionnaire. What does this secret do? Why was it in your public repository? And that way you can combine all this information and really be able to target the incidents that affect your organization the most. And some other areas is that you can obviously monitor how your organization is doing over time with analytics. So it'll also let you know how many secrets have been triggered and if that number is going down or not. So very quickly, there's a lot more to this, but I'm running out of time. I just wanted to give you guys a quick taste there. We are. But one of the cool things about GitGuardian is that if you're interested and you first want to know what your exposure is, because we have that historical data, we can actually spin up a dashboard for your organization and show you your real-time exposure, your attack surface. And we'll do that as a proof of concept. So that can be completely free for you if you're investigating in the product. So that's really good just to know that, hey, do we actually have exposure to this problem? Or is it just other companies? So obviously, that's something that you can certainly find out for yourself. So just some other areas. GitGuardian really helps you monitor your perimeter around the clock. So there's lots of components that we've talked about. There's monitoring, which is establishing that perimeter, being able to kind of check in real time what's happening. Detection, being able to find those secrets. This detection part is really key to use a high quality detector. But in my opinion, it's actually a lot of the other stuff surrounding this that's more difficult to do effectively, including being able to alert you in time and sending it to the right place, so your right scene, being able to respond appropriately. And the other cool thing that I didn't talk about here is that if you have a red team, well, you can actually use the product from a red team perspective and try and find threats in your perimeter in your red team activities. So it can be both a blue team and a red team tool, which personally I think is really cool. And here's the typical logo slide that I think you have to have, right? With this to prove that we're a real company, we work with other real companies. But yeah, so I'll finish up here because I've managed to finish just on time. But a good opportunity, Chris and David. Do you have any comments kind of following on from that questions? And anyone in the audience that wants to ask questions, there's a questions tab, Q&A. You can fire them away in there, and I'll do my best to get to them in time.
No, this is such an important topic right now with everything going to open source. And, I think it's a very excellent presentation, Mackenzie, by the way. You did a great job. But this is something that our enterprise clients are all, we get, like I said, we've got probably four calls a week right now talking about, this very specific challenge that these big companies are having, because they're trying to get past, they're moving security into the CI/CD as quick as they possibly can. And it's, it's nice that this tool's out there.
Yeah, great job, Mackenzie. I think it was the tip of the iceberg. You squeezed a lot into an hour. I would encourage everybody to go have a deeper dive on GitGuardian and all of its capabilities. And I think it's going to be extraordinarily important for any organization. If you're writing code, you got to be doing these kinds of things. So well done to you and the team at GitGuardian. And thanks to everyone for joining today. I think that as we come together as a community, we make the whole universe a bit better in this space.
Yeah, and thanks both of you guys for being in there and your interjections. It's been it's great to have people with such experience in the industry to talk about this, and it's great to see that it's starting to shine through. Not just me rattling on about this about this problem into the void of the internet.
Great.
But yeah, I'm just checking through the chat to see if there's any questions that are coming up here. We do have one from Umo. Are the most common credential leaks based off public commits and unknown public repositories? I think I get the question, but actually, when you're talking about the most amount of leaks, we're only talking about public repositories now. If we were to talk about private repositories, and we do have stats and different products for private infrastructure and repositories, man, the problem is so much worse. And if you look at the case of Uber, which recently happened, someone made it onto their system, it was even able to bypass MFA onto their server, and in their server was admin credentials for their PAM, their privileged access management. It's like a secrets manager and a password manager together, and the attacker was basically able to access everything. So when you talk, so public is just the tip of the iceberg in terms of the problem, but it's the most visible, and I think probably it's some of the most fun to talk about because there's a lot of public leaks that do happen. All right. Well, I think that brings us to the end. We're 1 minute over, so I'm glad we're able to just make the hour presentation. So thanks everyone for joining and participating, and a special thanks to David and to Chris for sharing your opinions on here, because I think I really enjoyed